So let's get going with the wallet and repository objects. You can pull the code base for that particular task by doing git checkout task 5. I'm going to resync my Gradle. Fix the Gradle bug we had yesterday, by the way. Thanks. Thank you to Steve who proposed. It was about the JDK location of the JDK, which was exactly the problem. And another aspect that I had questions about yesterday was the layout of some of the folders. And one thing that I didn't really address was how when you look in the source folder, you have 3 directories: the main, which is the one we've been using, and then the test and the Android test. The test folder has unit tests. So those are like pure tests that are simple and don't make use of Android at all. So you're testing elements of your application that don't know they're in an Android app, for example. You know, if you have a method that returns a number after, you know, doing some calculations to it or whatever, something like that, this would be the type of tests. They belong in that folder in the test. So those do not know about Android. They're just Kotlin language tests. And then the Android test folder usually will have much more involved and complicated tests that require the whole like loading up some of the Android framework and creating like mock UIs and testing that those behave as expected. So, but tests are outside the scope of this workshop, so we're just gonna keep going. That's right. Good point from Steve. I should let you guys know where I found the fix for my JDK settings. So sometimes this has happened to me on both on my Ubuntu machine and on this one. But if you go up here, I don't know if you see on my screen the small icon project structure. If you click on this, you get a lot of options that are allow you to fix basically your IDE. And the bug, just to be clear, yesterday the bug was not in the code or the compilation, right? We were able to compile it and run the app. The problem was the Android Studio, the IDE was not recognizing was not finding basically the JDK in the path. So and it was, my problem was right here. So JDK location, had to choose a different JDK location. If you're on either Linux or Mac, and actually I think Windows as well, if I'm not mistaken, I really recommend using SDK Man if you're dealing with anything Java, Kotlin, Gradle. I mean, it really is for a lot of things. And this will allow you, this is sort of like the NPM, the equivalent of NPM or Gradle or, sorry, not Gradle, Cargo for Rust, the compilation pip for Python. So it allows you to sort of like, it's not the equivalent, but it allows you to pull a lot of different versions of Java and change them. So if you have a problem, you have one project, you need to compile it with this Java, you can just pull it by basically installing it. And this is what's happening here with my command line. So if I do, I'm just going to clear this for you folks. And so if I do SDK list Java, for example, it lists all the Java versions that I have available right now that I can like download. And once they are downloaded and installed, I can switch between them. And I can switch my Java version for that particular, just that particular terminal if I want to run a specific thing in there, and all the other terminals stay the same, or I can change the default one, and I can do the same with Kotlin. And so it's a really useful tool. And once you have it set up, it works wonderfully. So that's how I installed the Java 11. And here I'm pointing to it in my Android Studio. So that's how the bug was resolved here. You can see that the JDK location is under SDK Man, which is the application. Let me know if you have any more questions on this. So we're on task number 5, and I want to, this is getting cool. We're having a lot of fun here. So what we're doing is I brought all the wallet activity and the wallet choice activity under this wallet package, right? So now the fragments, and these are like navigating between each other and whatnot. So we saw those yesterday, receive fragment, these types of things. We have the buttons. Also, one of the comments I got yesterday was that I glossed over a lot of Kotlin code. So I'm happy to dig a bit more. If you have like syntax questions, ask them in the chat. The first time you see a language, it's, there's always, what's this question mark doing and these types of things. So I'm happy to dig a little bit more. But what we're doing with this task is creating these two big classes, these two really, really important classes. The first one is called the wallet class. And this is really where the Bitcoin dev kit is happening. So first of all, this class is an object class. And so in Kotlin, an object class will create a singleton. Singleton is a design pattern that's so used everywhere and so famous that they've actually made a keyword for it. And it will basically enforce that there's only one object of that class that's ever created. So you can't have multiple wallets floating around. And this is really important because this wallet class will load up the library, the native library. So this, again, to sort of like remind you, we have compiled this native library that targets the architecture on your phone, right? And so that's it. The particular one that is running on your phone is just about 35 megabytes, maybe like 40 megabytes. So that's the native library. It's not Java and it's not Kotlin. And so we're going to need to load that, and we're loading it as part of this wallet class. And if we had multiple wallet classes, then we'd be loading that in memory, like 4 times or however many times we create a new wallet object. So here we only create one. We need to instantiate it, and once it's done, it'll be there for the duration of the application's life, and that's why we're using the object keyword as opposed to the class keyword. So I'm pulling this object, and as part of this object, notice here my line number 18. This is what I'm doing. I'm defining this Electrum URL that we're going to use, and it's the electrum.blockstream.info. So this is where you would add probably, you'd make that sort of string a value that could be changed. And the init blocks, if you're looking at init blocks in Kotlin, they are basically what gets run immediately as the object is created. So whenever the object is created, what will happen here is we're going to load this library that we've imported here. And see private value lib. So we're using the load method on that object and storing it into the lib variable here. And from there on, I can use lib dot whatever method I want on that library. And so here, this is what's happening. You're going to see it in the in this, for example, line 85, where we say lib.sync. So this is basically the workflow for calling the Bitcoin dev kit is going to be lib dot whatever method we have defined on that library. And here, notice the get new address method at line 89, which returns lib dot get new address. Again, so that's sort of what we're doing. And this these methods require a wallet to be given to them, and so we're passing the wallet pointer. So this is, again, this is a native construct, so it doesn't exist on the Kotlin side. It exists on the native side, and so we need to provide a pointer to it so that whenever the library is trying to play with it or add something or go into the database, get something, it needs to know where that wallet is. And so the wallet pointer is defined above, and we're basically using that wallet pointer again and again. Whenever we call the library, we also give it a wallet pointer to say this is the wallet, because in theory, you could also have multiple wallets. Any questions so far? Okay, so we'll come back to this class because it's the most important one of the task, but I want to briefly touch on this Sobi wallet applications. So far, we've played, like we said yesterday, we've played on Android's turf, and Android provides two big pieces to develop, two big classes that we want to extend to develop Android applications. It's the activity class and the fragment class, right? And so activities are like the big pillars, and fragments are like the mini screens that are within those activities. Here, I'm extending a third type of class. It's called the application class. And the application class is a really important one. And it gets, you don't need to have it declared. So if it's not declared by you, it'll just run just empty the way it's defined by Android. But if you want, you can also fire it up at the beginning and add a few like little things that you need done. So that's usually, it's not something you want to have a lot of code inside of your application class, but a lot of applications will define a few things there. And what we're doing here, if you look at my line 18, I'm defining a path for the wallet. And the wallet is initialized at that moment. So as soon as I fire up a method on that object, it's sort of like lazily loaded. So it immediately gets created. So this is where the wallet gets instantiated. And this application class gets fired up at the very beginning. So it's the first thing that happens. We fire up this application class. So the wallet gets created immediately. Boom, here we go. And the other thing that's happening here is my line 21, where we set the shared preferences. And shared preferences are the other part of this task that are important to understand. Shared preferences are small utilities that are offered by Android. There's actually a new one that's sort of replacing shared preference. I can't remember what it's called. It just came out a few weeks ago, but shared preferences is the idea that you might want to store a few pieces of data, but you don't necessarily want to fire up a whole database for it. So databases are, they're costly, they take time to set up and whatever, and it's a lot of code and you can have bugs in them. But a lot of apps require you to store like a tiny little thing, right? The name of the user, or whether some toggle was turned on or off, or if the preferred theme is nighttime or daytime, or these types of things. So shared preferences will store like very small things, just strings, and we go into them and we put either, like I said, like strings, booleans, integers, this type of thing. So this is what I'm using here, and I'm setting up my repository object as well, and basically firing up the shared preferences by saying we're going to give it a name and a context. And from there, the shared preferences are sort of set, and then we'll be able to pull on those shared preferences. So that's what the application class is doing. First thing it does, fire up the wallet and the repository. And this is what this task is about. So we're firing up the wallet class. And at this point, the wallet hasn't done anything. We're just setting a path, creating the wallet sorry, not even actually at this point, because we're defining a bunch of methods, but we haven't done anything yet. And whenever we take the break, take some time to go over the wallet class, because it's the important one basically. But what we're doing is we're wrapping over a lot of the methods that are offered in the library. So notice like this generate extended key method, that's the Bitcoin Dev Kit is offering that to us. And we want to wrap it up so that it works in a Kotlin way that anybody outside of the wallet class doesn't know about the native library. The wallet class really handles all of the communication with the Bitcoin Dev Kit. So anything outside of the wallet class has no idea about the Bitcoin Dev Kit. We are purely, they all think that the wallet class is the king of the world and is just creating all of this for free. And whereas really the wallet class is creating none of it. It's really the Bitcoin Dev Kit and the native code in the background that's doing all of this. I'm looking at what we have here. I'm using logs. If you're not familiar with the Android, this is basically how you would log something to the logcat. At the bottom here, I've got a little tab called logcat. When you're running your emulator or you're running on your phone, if you have USB debugging activated, you'll be seeing all of the logs. And those get like really, really big. So in general, you want to sort of sort through them by level, or if you keep it to verbose, it'll throw all the logs at you, and then you can search within that. And so what we're using is we're using the idea of tags. So my log here is of type I, so that's information. So here, see, I can choose between verbose, debug, and info. So the tags we're creating here with the log.i will be of type info. But more than that, I give it a tag called Sobi wallet. And so that makes it so that when you come here, you could say Sobi wallet, for example. It's not case sensitive. And from there, you'll be only seeing the logs that we've created. So that's a useful way to sort of, if you're searching for your own for your own logs. Does that make sense? So we have this log, right? Notice I've got this tag and then a message. And Kotlin offers string extrapolation. What is it? String template. I forget the name, but it's a $, and then you can use a variable name with it, or an actual expression in there inside curly braces. So you can do $, curly braces, and then put an expression, like you could say 10 plus 10, and then it would actually print 20 to the screen. Okay. And so we have things like load an existing wallet, initialize a wallet, right? Sync and get new address. So initialize is the big one there. And what we need to initialize a wallet is two things: a descriptor and a change descriptor. Easy, right? Because a lot of that has been defined. I'm hard coding the Electrum URL, the path, the network. We're hard coding this to be testnet. We're not doing mainnet on this. The name as well is hard coded. So a lot of that is sort of like predefined in our case here. So what we need is really a descriptor and a change descriptor. And I hope you're familiar with those. Usually in Bitcoin wallets, right, when you send coins, you're using UTXOs, but you don't necessarily use all of them. So you need to send yourself back some change. And the change that you send yourself back typically is going to a different sort of tree of addresses that the wallet also controls, but it recognizes it as being sort of change. If you're not sure what those do, let me know during one of the breaks and we can talk about change a bit more, but yeah, that's the idea. Does that make sense? So if you look at we had the initialize method below, and now I have a create wallet function, and the create wallet will basically call those methods that are important. We generate an extended key. So that's generating the descriptors using that extended key. So the extended key was what we did with the CLI earlier, just to show you here. But this call here with the CLI, right, was exactly that. We generated an extended key, which is this tpriv there. That's what we care about. And from that tpriv, because if you look at the generate extended key here, I'm passing the mnemonic word count to be 12, and then we're giving it no password. And so it'll return one of those sort of like 12-word mnemonic with actually, no, in this particular case, it only returns the tpriv part. And we're using that tpriv in the create descriptor and change descriptor. So if you look at my create descriptor and create change descriptor, what matters is my line 49 here. So we're returning a string with that xpriv in there, sort of like concatenated. That's actually not, that's not optimal. So I'm just going to notice that I'm concatenating the strings here. And what I should be doing instead is the $, curly braces here. This is how it should be done. There you go. So this is the proper way to do it. Or it's a more Kotlin way to do it, I should say. Both will work. Well, both will work. Any questions on this? This is the class to take some time. and try to make sure you understand. And as you extend the app, this is what you're going to be playing. So I want to show you sort of the workflow that you should be going through is, well, first of all, when you're in Android Studio, you can always do command and then press on, and then this is not going to work. Yeah, it works, I guess. Sorry. I want to show you the workflow of developing for this. What you'd want to have probably is a BDK JNI in front of you. And when you're looking at BDK JNI, you can go into the library, which is the Kotlin part of this, source main. And then we're back at our two files that we looked at yesterday, the lib and the types. And the types are, again, what's being returned, right? So you'll see what's available to you, basically. So in our case, notice that the generate extended key, for example, is returning the extended key type. So that's interesting. That's important. And if you go into, get new address, notice that it's returning a string. So now you know that it's not a specific BDK type. It's just a string that's being returned. So that kind of thing. And that the sync function is not returning anything. And when something returns nothing with Kotlin, what it actually is returning is the unit type. And you don't have to write it explicitly, but in this case, I'm going to write it explicitly so that it's obvious for you folks. And here, notice I have it here as well. I tried to put it pretty explicitly everywhere, but you don't have to. So, and then the methods we're using, right? So the lib.generate extended key with the snake case. Again, the way you would sort of develop for this is, or the workflow I would use is to say, you want to bounce between the BDK JNI and have a look at the methods that are defined in there, right? Destructor, get new address, sync. Those are all the methods that I'm using there. I'm doing lib.sync or lib.ListUnspent, and we're gonna actually, oh man, should have said that earlier. See, the idea that you should list maybe the UTXOs that are available to the user. This would be a great addition to the wallet, right? If you're not familiar with this idea, your wallet, a typical Bitcoin wallet, when it needs to spend, it'll show to you the entirety of your balance. So it'll be like all of the UTXOs that are under your control, how much they amount to, and that's the amount that you can spend. And when you want to spend to whatever address, you just say spend to this address, and the wallet internally will choose which UTXOs it'll pick. It's kind of like having a bunch of $20 and $5 bills and $10 bills or whatever in your pocket, or rupees, or $10 rupees in your pocket, and you can pull those out and choose which one to spend when you go to a merchant. It's a similar idea with Bitcoin, where you might want to choose which UTXOs you want to spend. And at the moment, the wallet doesn't offer that to the user. The wallet will always pick by itself, but you could definitely offer those UTXOs to the user, and the user could then decide which one it wants to spend. That's maybe a bit more advanced, but it's used a lot for privacy preserving techniques and wallets. So that's my idea. That's what I'd like to show to you guys, is the feature, the workflow of going between the BDK JNI with the types and the lib, and seeing what's available, seeing how they work, the function signatures, this type of thing, and then bouncing back to the wallet class. And this is the class, again, that's going to interact with that. And it's the only class that interacts with it. We don't want to see Bitcoin Dev Kit anywhere else in the app, right? The rest of the app doesn't know about the Bitcoin Dev Kit. We want to encapsulate all of that complexity in here, and nobody else gets to speak with the native lib. It's just, yeah. We want to
Thunderbiscuit, there's a question in the chat.
Oh, yeah. Thanks. I guess I don't see all the time the chat sort of firing up. Okay. If we want to add the option for a custom Electrum server, do we have to allow the user to configure the hard-coded parts like the Electrum URL? Yes, that would be the way. So you would have that Electrum URL, for example, we're just about to get into the repository class, so you're going to understand how this works a little bit more in a few minutes. But right now, the Electrum URL, my line 18, is defined, and you can't change it. But it could be, you could imagine it to be part of the shared preferences. So that would be, it would just be held in memory, and it would be, the app remembers it when you destroy the app, or when you turn your phone off or whatever. It gets kept in the shared preferences, and then when it fires up, it would just pull the URL from the shared preferences. And then shared preferences are changeable, are fixable, right? So you could have some sort of like settings screen that say, like, I want to change my URL for Electrum. So that would be how I would do it. In this case, we're firing up the wallet. We're creating the wallet with it, and the initialize method is creating it with it. So, and that creates the wallet pointer. There's a bit more complexity there, so I don't want to simplify it too much. There might be a little bit more reshuffling of the code, but yeah. Let's dig into this repository class. It's less work than the wallet class. And once we're done that, I think we're maybe ready for a break, or yeah. How does that sound? Cool. All right, so this repository class, the repository is a design pattern that is used a lot in Android development. And if you're not familiar with the design patterns, I really recommend this book, Head First Design Patterns, right? The standard Bible for design patterns is called the Gang of Four Java design pattern, or something like that. No, design patterns for object-oriented programming, or it's like C++ thing. But this is sort of like the human readable version of that Bible. And this book genuinely changed my life. So do what you will with it, but comes highly recommended. So, and design patterns apply to all languages in general. So like a lot of things are reusable. The ideas don't belong to a particular language. They really are sort of a higher order thinking, right? So we're building mental models for how to develop software properly. And so those design patterns, the Eric Freeman, yeah, yeah, exactly. Eric Freeman and Elizabeth Robson. By the way, I just want to say it's super cool that you guys are working with mentors this summer, and that's just a really good way to learn. I think that the return on that sort of stuff is really powerful, and kudos to whoever thought of the idea of like pairing people like that and just like spending a summer with mentors on working with projects, because I think that that's a really good way to learn. And as you move forward, I can't recommend that enough as a way of learning. I think I have developed good relationship with some other developers that are acting, as mentors to me. But also I have seeked out like mentorship from in a sort of a formalized manner. So I've been working with an Android specific mentor for almost a year now, and we meet once a week for an hour and a half, and I pay this guy. He's like a very famous like Google expert that I pay this guy to work with me once a week, and the return on this is unbelievable. So I think mentorship in general is really, really a good way to go. I think it's tempting to see at the beginning to just think, oh, I can just watch as many YouTube videos as I want and I'm going to learn it all. But the truth is, I think that the mentorship will sort of like is an extra gear on that. It'll just like magnify the speed at which you can take it in and the amount of stuff you can cover in the same amount of time. It's not that you learn more necessarily. It's just that you do it like 5 times as fast. So cool. And I hope that you folks continue with this and develop good relationship with your mentors, and maybe, you know, become, over time, we become coworkers almost with a lot of these open source projects. So that's super cool. Back to my repository pattern. Sorry, I know we want to take a break. The repository pattern is this idea that our Android app, a lot of the UI, right? We have a lot of these fragments. We don't really want the UI fragments to know and to make a lot of complex decisions. You would want these UI files to be very, very simple, and they don't really know anything about this whole like app or whatever. They're just like, from a fragment's perspective, the fragment is like, I'm just showing this screen. I have a button. That's all I do. You press the button. I don't know. Like, I turn around and I give the task to someone else. That's kind of how you want your application to think or to work. So a fragment will have a button, maybe, and whenever that button is pressed, what it does is it turns around and gives a task, the button press task, to someone else. And it doesn't know who, and it doesn't know how. You know, it knows who, but it doesn't know what happens there, right? And maybe it gets something in return, or maybe it just, that's all it does. And a lot of that complexity, that like, what do we send to, who do we, you know, who makes those decisions, what do we want to do, is going to be handled by this layer called a repository. That's the design pattern here, is to say, when we require, and you can find really good diagrams of that. I recommend during the break, like Google it just to find like a good repository pattern diagram, but it'll give you an idea of like what it conceptually looks like. But what we want to be able to do is to say, I as a UI fragment, maybe a UI element, I require some data, right? So my screen will eventually need to display the balance for the wallet. But you don't really want the UI. So the UI, for example, there might be multiple ways to get that data, right? So maybe that data for the balance is somewhere in the cache, so it can be like retrieved really, really quickly, and you save a lot of resources on that. Or maybe it can be retrieved as a cache, and so it would work even if the device is not connected to the internet, or if it has a poor connection, and right. Or maybe it doesn't have it in the cache and it wants to make a pull to the server. Maybe you killed your app and now you're bringing it back, and it's sort of like it thinks that something is corrupted, so it wants to make sure and just make another ping to the server. And so this decision of deciding whether to go with the server, or whether to like look at the cache, or whether to create something from scratch, maybe if the default doesn't exist or something like that, is a complex decision process. And you don't want those to happen in your fragments, because it's possible that multiple fragments will have to make the same decision, right? There's like, if you need to ask about whether you have enough balance to spend, that sort of questioning might happen in two different parts of your app. You don't want each of those to have to do the sort of like the questioning and the thinking through that idea. Instead, what we do is we create this upper layer that makes all those decisions, and all the fragments, the UI elements, simply they defer to that to make those decisions. So that's how it works. That's the idea behind the repository pattern, and that's what my repository is doing. And my repository is 56 line long, and take a look at what's in there. So we have the idea of shared preferences, right? It's a variable at this point. We set them, and then it becomes this variable called shared preferences. And then the repository will, in this case, it's like a simple set of instructions what it does, but it can answer the question of does the wallet exist? You might want to ask the repository that, right? You don't want to check that yourself. You want to leave that to someone else, and that's the repository pattern. So from the point of view of the dispatch activity, like we're going to focus on this particular method for a second here. Does the wallet exist? And it returns a Boolean. This is the function signature for Kotlin. You have a colon and the return type. And my line 22 there is creating this variable called wallet initialize, which is a Boolean. And what it does is it goes into the shared preferences and it calls the method getBoolean. And it needs a key because they're key value pairs. It's like a map. And the key is initialized. And then we say there's a default value to that. So if it doesn't exist, then the default is false. If it exists, then it'll return true. And then we just return that value. And this method, does wallet exist, gets used in the dispatch activity. So we had that last time, but it was not implemented, right? I had all of that commented out. It was always going to the same place. Here, it's a bit different. We're saying, line 23 here, oh, sorry, line 20, we're saying, is the wallet initialized? Repository.does wallet exist? And that returns a Boolean, and it's just this variable here. And then I can use it in an if-else statement here. If the wallet is initialized, so if the user already has a wallet on device, then we want to load it, right? So we're going to go to our wallet class and use the load existing wallet method. And then we can just start the wallet activity. So that's what happens here, line 25 and line 26. And if it doesn't exist, then we want to start the other type of activity, the one where we ask the user to choose which wallet they want to create. Maybe they want to recover a wallet that they already have using their BIP39 recovery phrase, or maybe they just want to create a brand new one. So that's what happens here. And if they do go to that, right, they go to wallet choice activity, they go right here, wallet choice activity. And if you look into this, it's, again, pretty simple, but what's important here is my line number 23, wallet.createWallet. And that's all it is. And then we fire the wallet activity. We just get going on the wallet activity. But again, we're calling this wallet class, this wallet object, sorry, and the create wallet method on it. And if I go on here, create wallet is this thing, which basically creates the extended keys and then builds our two descriptors that we talked about, and then calls the initialize method, which the initialize has sort of like the big of this whole thing. And once that's done, that's the other neat trick here. Once we've created the wallet, we need to save that wallet into the shared preferences, right? But the wallet class doesn't handle shared preferences. It only calls the repository to do it. So it goes to the repository, right? We're really going in a circle right now, so it's pretty cool. It calls the repository and it says, hey, repository, can you save this wallet for me? This is the path, this is the descriptor, change descriptor, and then save my mnemonic as well, so the BIP39 phrase. And if you look at my repository, I have a save wallet and save mnemonic. And if you save the wallet, it will go line 32, it'll go and put that Boolean true for the initialized key. And so the next time you fire up the wallet, you'll find that when you call the does wallet exist method, it'll say, yeah, there's a wallet here. Good to go. And so it'll go into the wallet and it'll load it. And so at that point, we're not calling the create wallet, we'll be calling the load existing wallet method. So those are sort of like the two branches of that tree where when we fire up the dispatch, we say, is there a wallet? If there is, then we either, if there is a wallet, sorry, we load it. And if there is not, then we create it. So that's the gist for this. So we haven't really touched any of the resources. The manifest has now these three activities, right? The first one of which is the dispatch, and otherwise my wallet classes, the fragments activities are pretty much the same. We just have these two, and I'm going to try firing it up, and we're going to take a look. Oh, we've got a bit of a UI problem here. This is the old app from yesterday, so it's still, if you look at the bottom there, it's still building. I think one of the comments I got from yesterday was that I was going really fast, And I don't want to repeat that mistake. I know that because there's not a lot of questions or interactions, I'm just like firing through, right? So, oh, okay. So take a look at this. Value of initialized in my logcat here, value of wallet initialized at launch is true. So this is why we end up going immediately into the wallet activity as opposed to going into the wallet create activity. And so it's actually giving me the descriptor, and look at that descriptor. That's exactly the path we talked about earlier. And there's a way to delete the data from the AVD manager, the AVD. I'm just going to quit this. We're going to try wiping the data on that emulator. Both my emulators there. And I think that if we fire this app again, now the data will not, the shared preferences will not contain anything. And so the default value will be false. And so it'll fire directly into the wallet choice activity as opposed to the wallet activity. Let's just make sure my repository here, yeah, my default value is false. While this is compiling, it's a good time to ask your questions. How does that look for everyone? Jonas, you were asking if this was the Eric Freeman version. Is that a book you read, or?
No, just trying to track it down. I can put the link in the side. I can maybe track down a PDF if people are interested.
Yeah, actually, that'd be good. All right, so if you're looking now at oh, I'm not sure why it's not in the logcat, but we're finding that now I'm firing, my dispatch activity is going right into my wallet choice activity. And here I can go into recovering an existing wallet, which that button doesn't have anything implemented on it. So it doesn't go anywhere, it doesn't do anything, or I can create a brand new wallet. And when I do that, it's loading the Bitcoin dev kit. So that's why it takes like a split second there. You notice that, yeah. Okay, sweet. All right. So I think we're good for a break. I want to give you a sense for where we're going next. I want to do a breakout room for 10 minutes maybe, where I'll let you try one of two things. You can either try to add a text box here between the button and the image that will add some sort of like information about the Summer of Bitcoin wallet or whatnot, right? Just a little paragraph, 1 or 2 lines, or add a completely new fragment. We'd want to add a third option here called settings. So this might be a good place where we could define, notice like our Electrum server maybe, or that sort of thing. Okay, so you're getting an error on the phone. Okay. I'm not sure what could be causing this, but sometimes it might have to do with your hardware. So depending on what version of Android is on your phone, that's possible. If there's a target version here, and I'll show you where it's defined. If you look at the build.gradle.kts file, we have a minimum SDK version, which is set to 23. So if your phone has an Android that's behind that number, then I assume that could be causing your error. So it depends on your phone maybe. And one way you can check that if you're not sure what version you have, there's an app called Droid Info, I think. Droid Hardware Info. Yeah. This is free. It's pretty sweet. And it'll allow you to, it'll give you like your CPU architecture, your, obviously manufacturer and VM number and SDK version. So sometimes when you're developing apps, there's like some more technical questions you might have about your phone or the whole setup, and it's hard to find, or sometimes they're not even, you can't find them. So Droid Hardware Info will give you that sort of like these little more advanced little tips. Cool. Happy to see that other people are having it work on their phone. So that's sweet. So at this point we have a wallet. Like if it's loading the wallet activity, the BDK is loaded and you've got a wallet on. And if you look at your logcat, right, because even if you're running it on your phone, your logcat will be firing. So you'll see the logs. Your logcat will show your output descriptor, and if you print a new address or whatever, it'll be there.